Guys, welcome to my YouTube channel, and this video is a little journal about how am I going to simulate a graph. And yeah, suddenly I got an idea like, why don't I simulate a graph like a three-dimensional one, without like using vertex buffers and connecting triangles. It is pretty much kind of boring. So like actually today I came across this one particular keyword, that is discard. So which essentially what it does is it just skips drawing that particular pixel or a fragment, okay, if this is included. So as you can see here, I have wrote a condition, okay, like x square plus y square is less than or equal to 0.23. Okay, this is nothing but a circle. And why I have included this other statement is that to distinguish the circle from a thin wire. So I just wanted to increase the thickness of the circle, so it should such that it looks like a ring. And yeah, so this is the actual circle equation, and this is just to add more thickness to it. So this is the circle of radius 0.5. So let us look how it is going to look like. So as you can see here, the image is a bit disoriented. This is majorly due to the normalized device coordinate feature. So basically what happens here is that the number of pixels between this end and this other end will be calculated such that this end represent 1. Like the pixel at this end represents -1 and the pixel at this end represents +1. So when the shader tries to draw the circle, it is essentially going to calculate the coordinate of the pixel using this system as reference. So when that happens, if we resize this window now, this will essentially change the shape or the orientation of this image. For example, let me just reduce the size of the screen. Now it looks like somewhat good circle. Yeah, it has a really good feature as a circle. So this is what happens. If we see here, the number of pixels between this end to this end is lesser than from this end to this end. Okay, so yeah, and there are much things to talk about in that, and due to interpolation and stuffs and the reference to NDC coordinates, it results in a disoriented figure. So in order to fix this, we are going to introduce a matrix called aspect ratio. Just now I have typed it out. So I'm going to like have the scale x, scale y, and scale z along the diagonal, and we need not worry whether it is a column major or row major, because this is a diagonal matrix. Even though if you take a transpose of it, it is going to result the same. So this scale x, scale y, scale z is essentially going to not going to change the length of the length of the pixels or the screen, but what it does is it reinterpolates the given coordinate of a fragment into what we want it to be. Okay, so let us suppose there is there is -1 at this end and there is +1 at this end. So exactly at center it will be 0, and somewhere in between 0 and 1 it will be 0.5. So let us say at this point it is 0.5. Okay, so when we change the ratio, the 0.5 might shift here. Okay, the 0.5 might shift here. Okay, so what I'm essentially saying is that while multiplying this matrix to a given coordinate, if the point has an x coordinate, let us say 0.5, it will land exactly here after multiplying with this matrix. So yeah, this is how we are going to reinterpolate the coordinates of the fragment in the fragment shader. So let me show it a bit visually, so it will be easier for people to understand such that. So let us say this is 0.75 and this is 1.1. Yeah. So as you can see here, this is the resulting circle. So as I have interpolated it, they reinterpolated the coordinates of the given fragment. So it kind of looked like this. Okay, so it kind of looked like this. This is how the reinterpolation happens. So if you look at this, I'm passing this matrix with a name. Like reinterpolating aspect ratio matrix with the name mat, and I'm just multiplying it with this given vector, which is coming from the vertex attribute object, and multiplying it, and the screen draws it fine. But when I send object coordinates to the fragment shader, using which the given equation is being evaluated, you might be wondering that this object coordinate is from vertex buffer object, but the GL position is having a reinterpolated coordinate, isn't it? How both are matching? So that is a really good question, and it will take you really deep into some cool stuffs about shaders. And yeah, as I said before, what I'm doing is the coordinate remains same. I'm just changing the coordinates of the given point into some other by multiplying this particular matrix, isn't it? So the coordinate, let's say 0.5, gets converted into 0.25, but when I pass it to object coordinate, the x coordinate remains 0.5, and into the fragment shader it just goes as 0.5. Okay, so the x square is 0.25, and it is satisfying this equation, let's say. Okay, so let us suppose the given x coordinate is 0.5 and y coordinate is 0. Okay, so the point is lying on x axis. So when 0.5 is arriving from the vertex shader. Here it will be 0.5 into 0.5, that will be 0.5, and it will be satisfying the given condition. So what happens here is that visually I'm changing the position. I'm changing the position of the point 0.5 comma 0 to 0.25. Okay, I'm just visually changing the coordinate of that particular point, but mathematically it remains the same. It remains the same. So what I'm trying to say is, to be precise, the visual effect is different from the mathematical equation which we are using here. So if you look at the image before the transformation had happened, it would look somewhat natural and intuitive to think about. So let us say before multiplying this particular matrix, the circle would have looked like this. So the same point, this is the 0.5, would have been located here. But as soon as I multiply this particular matrix with this one, what happens is that it just gets shifted. So the change is visual, but mathematically the result remains the same. Okay, the same point still satisfies the given equation before transformation. Okay, so when these things stay static isn't of much interest to us, because user might be changing the screen size according to his will, isn't it? So based on here, I have predetermined the window size to be 1200 to 800 pixel, where 1200 is the width of the screen and 800 is the height. So based on it, if we say that if we take okay, so yeah, so let us do a math here. If we say if we take the ratio between the width and height of the screen, then that will be 3:2. Okay, so essentially the the width is 1.5 times greater than the 1.5 times greater than the height of the screen. So what we need to do, we need to just multiply the x coordinates with 0.6666 such that both the coordinates will be same for a given number of pixels in between. So we get a perfect circle. So essentially this is nothing but the uh, the ratio between height, GHD, height and width, just multiplied with the x coordinate, and boom, you got a perfect aspect ratio to work on with. So the user might dynamically resize the window whenever he wants during the runtime. So when that happens, we need some function to fetch the window's width and height value for us. So in order to do that, we are going to use a JLFW function. So yeah guys, like this is the JLFW function which I'm going to now use. Okay. So the function is JLFW get frame of size, and to this we are going to give the window pointer and the integers which I have shown above. Now I'm going to do a typecasting here. Float. So because like height and width both are integers, and integer divided by integer will result in an integer, and if we get a decimal number, then it won't be reflecting in scale x. So as we see here, so in order to check whether the math is going right, I have just written a cout statement in advance, and okay, let us run it. Yeah, so as you can see, we got a perfect circle, and the aspect ratios of each coordinate is as determined. Now the only thing is that we are going to shift this entire thing into the loop. So control X. So we are going to keep it here, because like while the loop is running, we might resize the window, and the values of width and height both should be constantly updated. So as you can see, I have written it here. So the scale is undeclared. Okay. Let me just remove this keyword here, because like each and every time we declare, it is going to like affect our performance. I mean the scale x, scale z. So yeah, we have got it. We no more need the cout statement just for the sake of checking it. Okay, now I might use it there, so if anything happens, I might be able to debug it easily. So now let us run the same. So something is happening in between. So let's see. Let's add a new line and try to run the same. Okay, as we see here, the like the given scale x and scale y scale z are being updated, but this matrix now, this is not being updated because this is static here. So we're going to shift the entire thing into this. Okay, so control V. So now type out the same aspect ratio is equal to mat4 1.0f, and yeah, good. Okay. Now this will work. So even if I resize, we are still left with the same circle. Okay, let me stretch it a bit further there. Yeah, same. Okay, the resizing part is done. So successfully we have done. So we no more need this say out statement. Let us write a comment statement for reference. Aspect ratio. Okay, dynamic aspect ratio. Values and dynamic size feature. Okay, so yeah, everything is good to go. Now the next step is that we have successfully resized the window. Okay, fine. Like why don't we play around? Just change some equations here and there. So let us say let us take the equation y is equal to x square, which is greater than or equal to 0, and the other equation should be minus good 0.01. Okay, so let's see. Oh, we're not even getting an image. It's because the thickness is very small. That's the reason. Okay, it should be negative. Yeah, it should be negative. Why? Because like if you take a point inside a parabola, as you go inside, the equation will return you a negative value. As we move outside, it will return a positive value. So yeah, that's it. So even for a circle, the case is same. The same case applies there as well. Okay, so let's. So the next step is to create a graph mover. So if we want to, get a full picture of a given graph, we need to be able to resize it, isn't it? So in order to do the same, we are going to alter the same aspect ratio for it. I said before, this is what I did. I just like increased the size of the plane up to 100, and I have added this particular variable named resize, such that I will be multiplying this variable with the scale x, y, and z. So accordingly, when it is multiplied with the point, that is the coordinate of that point, each and every coordinate will be enlarged by that particular constant. I mean, like multiplied with that particular constant, and it looks, it gives us the effect of zooming in and out. And so I have added these two if else statement, and so in order to detect whether any input is given from the keyboard or not, and z will be zooming out, and I will be like zooming in. I don't know why I gave this, because like I had only these variables left. So it's time to run and check it out. Yeah, so as you can see here, we can zoom out comfortably. There is no, oh my god. Yeah, so we have a problem here, that is when we try to zoom out even further, that is when the resize value becomes 0. What happens is when I try to zoom out, it becomes negative and flips the sign of the graph. So when that happens, the actual graph doesn't sustain after that. So in order to prevent that, I'm going to add another condition here, and then resize should be greater than or equal to 0. So and same goes there as well. Okay, so now let's check it out whether the things are actually working or not. So resizing the screen, Control Z, zooming out. How? Yep. So as we have seen here, things had changed. Okay, so when it becomes 0, the graph completely vanishes. So let us set it to 0.00001. Okay. So actually, I have heard from many people that instead of giving using the value 0 in terms of graphics, because it gives us precision error, we can go with a smaller variable like this, and it will give us better result. Because when it becomes 0, this if else statement doesn't execute. So when it doesn't execute, it naturally like zeroes out every coordinate which is present. So let us check whether our logic is working. Yeah, ours is working fine, but as you can see here, the thickness of that line is reducing as we move farther away. So we need to do something about it. Fragment shader. So when you look at it, what we have did is, to ensure it has a good amount of thickness, we have added minus 0.01. But the problem here is that inside the region, that is inside the concave region of a parabola, the values of any point in that would be giving us negative value. But if we check out the same value will be equidistant from everything or not, then it won't be. Okay, so why? Because that's how a quadratic equation works basically. So if we take a quadratic curve like this, so then any point inside would give us negative value, but what value? So if we take this point, and when we compare it with this x coordinate and y coordinate, it gives us 0.001. Yeah, fine. But when we move farther away, that point comes, like that point closes in, so the thickness reduces as it tends to infinity. So we need to solve that problem. So like I have a better idea. So to make this one dynamic and like based on its size, it needs to be like updating itself. So doing so what we could do is that what we could do is that we could introduce another quadratic curve which is just above this one, and if that one is you know if that one is like how to say, enclosing some region, let's say, then both the slopes will be parallel and the curve will also be exactly maintaining the same width. So let us check it out how it works. So what is the curve which is exactly above this y is equal to x square? So if we see, that is x plus 0.01. So yeah, so we are going to take this equation and plug it in here. So plus 0.01, 0.01, this should be greater than 0. Okay, so what we are essentially saying that is the points must be, okay, so what this one says is that the point should be oh, yeah. So what this equation says is that please consider the points which are just inside the parabola. Okay, what this equation says is that please consider a point which is just outside the parabola x square minus y plus 0.07692. Oh my god, this is resembling the same equation though. Anyways, let us hope this works. Oh, guys, like previously I was talking about that equation, right? Actually both are same, and whatever I said before is actually the thing which is required, but the equations before and after both are same, and what I intended to do was also same. So like right now I have an idea. So let's say I am having some constants. Let us suppose some constant k. Okay, float k. Yeah, so this k I will be multiplying with 0.01. Okay, to like increment the value as I zoom out. So what happens when I resize is that the coordinate for each pixel gets reassigned. So as I zoom out further and further away from the plane, the coordinate for a single pixel shrinks. So as a result, this particular 0.01 thickness is only true when a single pixel or more than one pixel is required to represent the coordinate the coordinate difference 0.01. Okay, so I hope you are able to get it. So there is a let us suppose this is one pixel and this is one pixel. So these two pixels constitute 0.01 coordinate difference. That is the difference between two coordinates, x coordinate. Let us suppose it takes 2 pixels to fill the gap. So as I zoom out, the coordinate designation gets reassigned. So as a result, now this single pixel now constitutes a coordinate difference of, let us say, 0.005. So that means we will be able to perceive the thickness between two different graphs, that is the color, only when if it is at least colored for one single pixel. But one single pixel will support a coordinate difference only up to 0.005. Then this gap is like this gap is very very less or small in order to represent this thickness. So 2 pixels constitute the difference 0.001 in initial case. So as I zoom out, the single pixel supports a difference in coordinate like 0.005. I hope you are able to understand. So cut from here. So as you can see here, let us suppose these two vertical lines are pixels. These two pixels constitute 0.01 coordinate difference. So for example, along x-axis, we are taking an array of pixels. So in that array of pixels, let us suppose these two pixels are adjacent to one another. So for traveling from this pixel to this pixel, it takes 0.01 NDC coordinate. Okay, so it takes 0.01 NDC coordinate. So as I zoom out, what happens is that these coordinates gets reassigned. So uh, such that a single coordinate only constitutes or okay, to be precise, this value is not accurate for example purposes. Let us suppose as a result of zooming out, the single pixel gets reassigned with a coordinate difference of 0.005. That is, like when I travel from this pixel to this pixel, the NDC coordinate changes 0.005. So in order to represent this, that is the thickness, that is the curve, at least I need a single pixel to represent the thickness, or else I wouldn't see any difference or even a line also. Okay, so to produce a line, I at least need a single pixel to represent it with a color, right? So when this happens, when the single pixel gives a change in difference of NTC coordinate as 0.005, so the thickness is no longer detected by the pixel itself. Okay, I hope it is clear for you guys. So now let me just erase it. So now this constant, it is somewhat related to resize, isn't it? So yeah, because when we resize, the pixel coordinate gets reassigned. So okay, I have already written out this particular thing here, so there is no problem for me to continue further. K is equal to some, let us suppose we are creating a uniform variable of float. Let us suppose resize itself. Okay, resize equal to resize. Okay, now this will be going it won't be interpolated. So just because I use flat, the values for each and every fragment will be same, the constant will be same. And here I need to get the location, right? So I need to get the location in order to update that particular variable inside. So its name is resize. Okay, now that since it is a float, I'm going to make use of this GL uniform function 1f, and since the location is location 1 and the value which I'm going to send is 1 by resize. Okay, okay, so why 1 by resize is because, like, when we multiply the scale xyz with resize, what we are essentially doing is we are scaling up the coordinates, isn't it? So when we scale up the coordinates by a particular constant, it tends to reassign the coordinate for each and every pixel. So we are going to nullify that effect by dividing it here. Okay, by dividing it with this. So when I resize, for example, I am resizing it by a factor of 0.5. Okay, so that means I will be incrementing the pixel thickness by a factor of 0.5. Okay, by increasing it by a factor of 2. Okay, so that would be more precise to say I will be increasing it by a factor of 2. So because of that, the thickness remains constant for whatever value it might be. Okay, so yeah, so let us check it out whether it is working or not. Okay, link. Okay, there is a problem, I see. Okay, let us try again. Yeah, now it is compiling fine. Work. Okay, what is happening? Zoom in, zoom out. Okay, there is a problem in shader, I guess, most likely. So since I'm sending a value resize on cases, so I'm implementing it right. So the name is right. It is a float, flat out. Okay, float k is equal to resize. Yes, it is being assigned. Yeah, flat float. Okay. Flat in. It should be in. Okay, flat in float. Now I think it will work. Yeah, it is working fine. I see. So even if I zoom in further and further, thickness is not changing. The thickness is remaining constant, even though if I zoom in or out. Okay. Okay. So as you can see here, let me reduce the speed at which it is getting resized, so it will be clear for us to perceive it intuitively. Okay, so now it is fine, I guess. Yeah guys, this happens a lot of time. Never mind. Okay. Now it is more clear to perceive. Okay, as you can see, the fragments are becoming dotted as I zoom out. Okay. Okay, so we need to analyze the reason for it. Okay. Oh my god, we are getting a dotted line. Okay, it's fine. So I guess like I think multiplying it by 2 will help a bit. Okay, the thickness is increased. Let's see whether it is giving us dotted line or oh, still it is giving dotted line. So the thickness isn't the problem. Hmm. Okay, so yeah, we have successfully resolved this resizing issue and thickness problem. Yay. So yeah, I know how you guys feel, like how I ended up getting this 1 by resize and why am I using it. It might be like intuitively difficult for you people to understand why it is, but like even I can't explain it that clearly because it was my gut instinct, as I'm used to like do these kind of stuff previously. I got a intuitively got this idea, so that's what intuition means, right? This point. Okay, so I'm going to explain that particular topic once again. Let's give it a shot. So why I'm using 1 by, I'm passing the value 1 by resize is that if we see, let us suppose before even zooming out, you consider the x-axis in this openGL window. So there are an array of pixels lying on the x-axis. So initially, before transformation, it takes 5 pixels to produce a change in NDC coordinate system by a unit of 0.001. Okay, so I need to travel 5 pixels in order to change the coordinate by 0.001. But when I zoom out, it only takes me 2 pixels. So from there, what can I say is that, okay, so it is not inversely proportional, it is proportional. So from that, what can I say is that the change in coordinate, so not the coordinate factor, so it would be a little confusing for you guys. So change in coordinate is proportional to the resizing factor. Okay, so let us consider before resizing there were there is a x-axis. It is of 2 pixel of thickness. Before resizing, that is before zooming out, it took 2 pixels, and after zooming out it take only 1 pixel, and even after that even 1 pixel wouldn't satisfy that given thickness. So the change in thickness was very large. So the change in thickness for a given pixel was very large, so that didn't happen. So the no pixels would have colored up. Because of that, no line was appeared on the screen. So due to that, we had to pass this 1 by resize into the uniform variable, since the thickness or the change in coordinate is proportional to the resizing factor. So when we divide thickness by the coordinate, sorry, thickness by the resizing factor, it will result in a constant. I hope you guys would have understood this. So let me just clear it up. Let's have this alone for future references. Now I'm done with the key control. So I have added the keys like A, D, W, S to control the the view position of the camera. So these are the conditional statements which I have written inside. Okay, so you see before, and I have used the translation matrix for it to change the position, and I'm just updating the vector over time, not the entire matrix. So there is an advantage of doing that. Instead of either you could newly send a translational matrix by distance of 0.001 or by a unit you desire, but that would be inefficient because you'll be thinking like you'll be multiplying it again and again as you move further and further away. But matrix multiplication is a bit complex and it requires time to run. So because of that, that is not desired here. Doing this would be pretty much efficient. Now let us check. Now I'm pressing the A key. So yeah, the camera is moving towards right. Now D. Now S. Yeah. Now W. Now R. Z. Let us go a bit further up. So you might be seeing this discontinuous line, and yeah, so you might have guessed what would cause this. And the answer for this is that since two graphs are, like both are quadratic equations and both are quadratic graph, but just shifted by a unit distance, like shifted by a distance of unit 0.001 in NDC coordinates. So because of that, those two graphs will be meeting at near infinity. So what does that mean is that the thickness between these two graphs would be reducing as we move away, further away and away from the origin. So because of that, because the thickness is reducing, when it goes, when it reduces beyond the thickness which a pixel can offer, this breaks down. So we need to fix this, or otherwise, our simulation will become a bit chunky, and we don't want that to happen here. Things simple. I have just came up with a 3D circle, like 3D sphere equation. Okay, so yeah, this is the thing which you are seeing right now, and I have added another matrix in order to add more number of plane. Okay, so this matrix is okay, it's not change position, it's uh, plane rotated. So see, what this matrix does is that given a 100 into 100 plane, it just tilts it by some angle. Okay, so it tilts it by some angle. So as it does that, what happens is the plane gets rotated, uh, and while it is being passed through vertex shader and then fragment shader, the x and y coordinates of the tilted plane will be evaluated. So as you can see, this will give us the uh, equations, cross section of the equation at different angles. Okay, so that's what this plane does. So this plane cuts the sphere into different cross sections. For this case, it is 45 degree. At an angle of 45 degree, it just slices the sphere, and just we are seeing its cross section. So here what my idea is that we have we are going to draw 4 different planes at different angles, and we are going to make it rotate with respect to time. So when we do that, we get an illusion of a whole sphere, or a whole, an ellipse, or whatever shape the equation describes. So we get that illusion because, like, cross sections varying over time will, like, overlap with each other and give us the effect of a given graph, or an object which we have described using that equation. So yeah, without wasting any further time, let us, like, introduce another matrix in order to make the rotation change with respect to time. So, and before that, we need to opify this, because, like, see, these many times I have just written draw element, so which is not feasible and doesn't look good as well. So let me just introduce a class to maintain all this. So let me name this class as draw call, and it has in the public section we are going to write our methods in that. So void draw. So inside this we are going to pass a matrix of 4. Okay, and we are going to exactly what we are do is, let's just copy paste the same thing. Control C. Okay, let me change this name into matrix. This one to be okay, fine. And the location unsigned location. Okay, so let me replace this with location, and so yeah, there are more than one locations for it. So I guess okay. So since I'm not interested in creating any more private variables, okay, I guess I have no choice to private. Okay, let us keep this aside. So just we will make another another method for it. Or okay, no problem, since we are dealing with these two. Unsigned it, location. So location and the constant just float. Okay, that's it. We are good to go right now. Yes, we are done. Now we need to declare the object outside this there. Let's do it here. Draw call object. So draw call draw. So now the first step is we are going to replace this one. Draw dot Draw. This naming is a bit confusing, but for now, in order to check things, we are keeping things simple. Later, we will just update it such that it is flexible enough. Location 0, location 1, comma, resize. Yes. Yeah, now we are done. So paste the same. Now just change this. Now erasing all this. Now, okay. So now we have this. Okay, let me rename this object because it's kind of awkward for me to just give it a random name. Okay, so the object 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 yes, object drop. Okay, so now let us run this and see whether the code is working or not, whether I have did any mistake or not. Yeah, it is working fine. So as you can see that different cross sections and things. So now it's time to make this thing rotate. Okay, so so actually I have declared this variable outside this while loop here, so which is a static one. So we are going to uh, initialize this. We're going to copy paste this one. Control X. Let us assign this to identity matrix. Let's say. Okay. Now what we are going to do is that Control B, and yeah, here we go. So play rotate is equal to this much. So now we are going to make this angle. Okay, so let's say till so delta. So actually what this function does is that it just calculates the difference in time between first frame and the second frame. I have just written it in the header file over here. So yeah, this the del time is this is what del time is. It takes the time at which the last frame was drawn and the time at which the current frame was drawn, and just returns the difference between those two. Okay, now let's get back here. Okay, instead of passing del time directly, we have to have some sort of control over it, isn't it? So let us create a new variable here. Code speed is equal to, let's say 50. Okay, 50 into del time. So del time be the same. So let del time be as it is. Speed we are going to implement it here. So in 50 is being multiplied with this one for each and every frame. So let us suppose this 50 is the omega, that is radians per second angular velocity, and del time is the time taken. So which essentially gets translated to speed into time, which is equal to distance. In this case, it is angle. So let us see whether things are working out well or not. Okay, so we are not seeing anything yet. Okay, this seems to be not spinning very well. So let us test it out whether it is spinning or not. So let us write a CF statement demonstrating this. Let us check. Okay, so Wait, these values are very, very, very small. 0. Oh, okay, that means the delta is probably here. Let's see what delta is. Okay, since the frame is being drawn at a really high speed, we won't be able to see much because the rotation itself is very, 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 very less. So now let us change the speed to, let's see whether we are able to see any difference. So as you can see, we are able to, not in actual sphere, but somewhat similar to. Now let us make things even more interesting. Okay. Like right now, I've technically hit the roadblock, and whatever mathematical technique I use, it's not helping much. And if you guys have any idea to like how to plot a 3D curve or a solid object for a given equation, please do share in the comment. Right now, I'm going to end this vlog for now. And yeah, I have searched many materials and asked certain AIs about like what is the process and how does things work and how can I get it done with OpenGL. It seems like there's a lot to learn for me. So I think that it's not the end. Maybe I would do a part 2 about the same shortly. So if I'm able to complete, then I will be sharing you the video. So yeah guys, thanks for watching. This is the end of my first journal.